Okay, example 1a and 1b both involve a letter squared equals a number. All right, and in general, when you see this structure, there's no linear term, there's just an x squared and a constant, just an x squared and a constant. There's a rule that says if x squared equals a, then x equals plus or minus the square root of a. That's just the rule. Okay, it's a real simple rule, straightforward. And in this case, x squared equals 4. That means x equals plus or minus the square root of 4, which means x equals plus or minus 2. If you can evaluate the square root, you should evaluate it. Or simplify it as much as is humanly possible. I do not want to get decimal answers for radicals right now. I want you to get simplified radicals. If that means the square root of 12 is 2 times the square root of 3, I want it looking like that. I don't want it to be broken down into whatever square root of 12 is, 3.46 or something.
Does the x squared turn into plus or minus because it could be either or?
Yeah, because if I square negative 2 times negative 2 makes positive 4. Positive 2 times positive 2 makes positive 4. So when you're squaring x to get a positive number, there's 2 possible solutions to it.
Okay.
Both positive and negative. Because when you square positive or square negative, you're going to get 2 of the same signs. You get a positive result every time. With that in mind, what Alexis just pointed out gives us a little bit of a problem here for this x squared equals negative 9. It's not possible to multiply a number by itself to get a negative number in the real world. Okay? In the imaginary world, it is possible, so we're going to investigate imaginary numbers today, and it looks like this. Okay? So if I apply the same rule here to this problem that we just used a moment ago, this says x squared equals anything, x equals plus or minus square root of that anything, right? So x should equal plus or minus the square root of negative 9. That's what it should equal. But in the real world, it's not possible to multiply a number by itself to get a negative result, right? Negative times negative makes a positive, positive times positive makes a positive, positive times negative makes a negative, but if we're squaring, we're supposed to multiply by itself the same exact thing. So it's not possible to get this result in the real world. The problem is the negative sign. So if I take that out, so if I get plus or minus the square root of negative 1 times the square root of 9. By the way, we're not going to be doing it this way all the time. Okay, there's a quicker way to get to where we're going. We're just not there yet.
Did you say negative 1 times negative 9?
Yeah, square root of negative 1 times the square root of 9. All right, because negative 1 times 9 makes negative 9, right? So we're just breaking it apart like this. What's the square root of 9? 3. So the only issue with this whole problem that we've got sitting on the board here is this square root of negative 1 is hanging out here, causing problems, being hard to get along with. So here's what we do with this. We invent an answer for that. The invented answer for the square root of negative 1 is the lowercase cursively written I. The square root of negative 1 equals I. Okay? I simply need you guys to believe that. I promise I'm not lying. That's what it equals. Now, I is not real. It's imaginary. It's made up. It doesn't exist. But I've invented this letter I that if I multiply I times itself, I get negative 1. That's how we create a negative out of a square. I times I is I squared equals negative 1. It creates that negative sign. All right? And if we do that, can we all see then that x is equal to plus or minus the square root of 9, which is 3, and then the square root of negative 1 is I. It's not very pretty there, so rewrite it. Okay. Now, let me just give you a little vocabulary here. Any number of the form bi is an imaginary number. So anything I is an imaginary number. So 3i is an imaginary number, negative 3i is an imaginary number. All right? Any number of the form a plus bi, a real number added to an imaginary number, is called a complex number. So sometimes I'll refer to a complex number, that means there's a real and an imaginary part to it. Or I might refer to it as an imaginary number, that just means it's an imaginary. 3i, 5i, 2i, 1/2 I, -7i, whatever. It's just something I. But if I say 5 plus 3i, now it's a complex number. It's got a real part and an imaginary part. When we write complex numbers correctly, it's the real part first, the imaginary part second, every single time. I want proper structure on these every single time you do it. It does matter. It doesn't matter today, it matters later. So I want to create a good habit now. So anytime we write a complex number, it's always real number first, always imaginary number second when we're writing these. Obviously, this only has an imaginary number too. And again, that's how you do these problems. If it's x squared equals positive, x equals plus or minus the square root of the positive number. X squared equals negative, x equals plus or minus the square root of the number with an I attached to it. All right, and that's how you do those problems.